Ish, with me here is a question. This one, it has been popping up over and over and over and over. This question 8.1. And if you don't know scenarios on how to solve, how to find frictional force, how to calculate normal force under this chapter, you will not be able to answer this question, because all of them are scenarios that they bring under forces, you see. So I want us to go through all the four scenarios and get done with them. Right, I hope I find you well. And then it's the same story. We keep pushing. No matter what, we keep pushing. All right, so the first scenario, you are given an object on a horizontal plane. This is an object on a horizontal plane, right? On a horizontal plane. Then it's of mass, let's say it's of mass 20 kgs, right? And then it's in this direction, there is force applied in this direction. Force applied, right? Then they give you coefficient of frictional force, which could be 0,2. Coefficient of frictional force does not have units. I'm pretty sure you all know that, right? So now, what are you gonna do? What are we gonna do? You know that in order for you to be able to understand a physics question, you have to come up with a free body diagram or a force diagram, a free body diagram. So the free body diagram for this object, it's a horizontal plane. It will be having 4 marks. So most definitely, you are going to have this side normal force that is perpendicular to the surface, and what? And Fg in this case, it's also going to be perpendicular to the surface, so they don't have an effect on the upward and downward movement of the object, right? Then in this direction, there's what? Force applied, and then in the opposite direction, frictional force, which always oppose what? The motion. That is our free body diagram with 4 marks. Right. So if you're asked to calculate the frictional force given then the formula to calculate frictional force, we say Fk equals to mu n, right? Where mu, that is the what? The coefficient, agree, of frictional force, and then n, that is our what? Normal force. Coefficient of frictional force does not have units. Why? It's the ratio of forces. So force, newtons and newtons will cancel. It's a question that came last year, November 2024, right? Why do coefficient of frictional force, why doesn't it have units? So the reason is that the ratio of forces, right, will cancel out the units because they are the same. Normal force and normal force will cancel out. You see, so right, that is it. So for you to be able to calculate friction, you have to calculate normal force. So in this case, you have to know that normal force is equals to what? Fg. Force is upwards, be equals to the force is what? Downwards, right? Which is gonna give us normal force is equals to what? Fg. You know that it's equals to what? It's the weight of an object, which is equals to mg. So normal force is equals to mg, right? Where m is the mass of the object in kgs, and g, that is the what? Acceleration due to gravity, which is equals to 9,8 meters per second squared, or 9.81 meters per second squared. It depends. If you are doing Cambridge, you're gonna use 9,81, but if you are doing CAPS, you're gonna use 9,8. If you are doing ZIMSEC, you're gonna use 9,81 as well. Just like the one they use in Cambridge, they use the sea level value. If you are doing ZIMSEC, you use 10. If I'm not mistaken, you use 10. Cambridge 9,81, and then CAPS you use 9,8. Okay, right. So that is the formula, which means frictional force here, you substitute normal force, it will give you Fk equals to mu mg. Since here our force applied is in the horizontal plane, you can just say cos of theta, which is equals to cos of 0, but is not that important. That's how you calculate the first scenario. Then second scenario now, This is the first scenario. We go to the second scenario. Second scenario, our force applied will be at an angle. Right, you are having force applied here, which is now maybe at 20 degrees, or let's say 35 degrees. So when you come up with your free body diagram, we are having normal force as usual. Here we have Fg, the weight of an object. Then in this direction, directed to the first quadrant, we are having force applied. And then in the opposite direction, we have what? Friction as usual, the one that we will be looking for. Right. So this is scenario number 2. So our frictional force, we're going to say Fk is equals to mu n. Now we need to calculate our normal force. So there is a new issue now that this force applied is no longer what? Horizontal. It's now having an effect on the frictional force. Why? Because when you are pulling something, you are lifting it. So the surface that is in contact with the ground is now minimum. You see? So it means the frictional force decreases. When you lift something a bit, you reduce frictional force. Let's say you are dragging a chair. When you lift it up a little bit, drag it whilst you are lifting it a little bit, the noise will be less. But when you are pushing it downwards, pressing it, it will make a lot of noise. You see, so in this case, you are lifting it up, which means this will have an effect. It's one of the forces that is contributing in the what? Upward movement, upward motion. So we're gonna treat it as what? Fy. This one, Fy. It's gonna have an effect here, Fy. So when you are now calculating normal force, in this case, you will say normal force is upwards plus Fy is equals to Fg. We can't construct here. You can construct if you want to calculate Fy. Fy is this side. This is our angle theta, that one which was given 35. So you go back to mathematics trig ratios. You have opposite. You want hypotenuse. So if you have opposite and hypotenuse, what do you use? You use sine of theta. That's why you're gonna see that here it's gonna be normal force plus Fy is the same as Fa sine of theta is equals to Fg. So normal force will now be equals to Fg, which is Fg minus Fa sine theta, which is the same as mg minus Fa sine of theta. That is the formula that you use for what? For a normal force. Now, frictional force, you now subtract this and you substitute in that formula, which means frictional force will now be equals to mu times mg minus Fa sine of theta. That will be your frictional force. You substitute your values in newtons. So that is the second scenario where you are having what? A force that is upwards, directed to the first quadrant or second quadrant. It will lift the object a little bit up. So frictional force decreases. Right, the third scenario, around here, the third scenario is when this force maybe is now directed where? To the fourth quadrant. You are having our angle here, we said 35 degrees, then the force is in this direction, like this. So our free body diagram is still horizontal plane, so we have normal force, Fg. Then here we have now force applied is now downwards. And frictional force is still in the same direction, opposite motion, the one we are looking for. That is our free body diagram, 4 marks for Mahala. Right, now, we now gonna calculate the frictional force. We say Fk equals to mu n as usual. It's there in the formula sheet. Right, but our normal force here is gonna be affected. That the scenario where I said you are pressing something towards the ground. Could be a chair, could be something that you are pushing. You are pushing. Scenario number 2, you were pulling. So here you are pushing. So you are sort of like pressing the object against the ground. So obviously frictional force is going to be much more higher. Alright? So you can see that this Fy, if we are to resolve it to the vertical, it's going to be here. We can label it as Fy. I don't think we need to construct again. You now know how to construct. Use the triangle. Construct here. So Fy that we are looking for is the opposite. Right? Opposite of our hypotenuse, Fa. So it means we are saying for normal force is now normal force upwards should be equal to forcing downwards. Fg plus Fy. Which is going to give you normal force equals to mg plus Fa sine theta. Right? That is it now. They are 18. Therefore, frictional force will be equals to mu n, where there is n, you put mg plus Fa sine of theta. Fa sine of theta. You see? So that is the third scenario. That is the third scenario that we are having. That is the third scenario. The last scenario. So we are now having an object on an inclined plane. Inclined plane. This is an inclined plane where we are having our object, same mass 20 kgs, coefficient 0.2. Then let's say there is force applied in this direction. So this is now our ground, the reference point. Our angle here will be having angle what? Angle theta. Let's just say, let's put a value, okay, theta. Angle theta. Right. So our free body diagram, we're gonna have this, then it's an incline. So we are having force applied here. If it's going upwards, friction is in the opposite direction. Fg is always what? It's always vertically downwards, and then normal force is always at 90 degrees here. 90 degrees to the surface. Normal force. Right. That is our free body diagram. Right. Then when something is moving up, obviously there's no way it's gonna sink or move upwards. No ways. Why? It's because here normal force is balancing with what? Fg perpendicular. And here we will have what? Fg that is parallel to the plane, the one that causes objects to move backwards when it's going up an incline or to slip downwards. You see, so that is Fg parallel. Then Fg perpendicular, it balances with normal force. That's the reason why here, when we are calculating frictional force, you're gonna say mu n, right? Mu n. But our normal force in this case is going to be what? Fg perpendicular. Fg perpendicular, we don't have time to resolve it, but when you resolve it, that is the one that is equals to m, that is equals to mg cos of theta, right? So Fg perpendicular equals to mg cos theta. Fg parallel is equals to mg sine of theta. You need to know these formulas, very important, especially the one for Fg parallel, right? So this one is gonna be normal force equals to what? Normal force equals to Fg perpendicular. Therefore, normal force equals to mg cos of theta. When we back substitute here, it will give us Fk equals to mu, where there is n, we are putting this mg cos of theta. That is it. That is the last scenario. Those are the questions that we are having. Yes. All right. That is it. All right. There's a question here that we can tackle. Is saying a crate of mass 2 kg is being pulled up to the right across a rough horizontal surface by a constant force F. The force is applied at an angle of 20 degrees to the horizontal as shown in the diagram. Draw a free body diagram, 4 marks. I have here the fourth scenario. I have I have flu, so forgive me. Right, so what we are having is this scenario where we are having force applied going there at an angle of 20 degrees. Then force applied we are not given. Then they say it's of mass 2 kgs. Right. Then, as shown, draw a free body diagram. So a free body diagram, we are okay with it, all of us. So there is what? Normal force as usual. Down there is Fg. Then in the first quadrant, there is what? Force applied and obviously friction. So each force will have a mark here. Each force will have a mark. Now they are saying a constant frictional force of 3 newtons. So frictional force is equals to 3 newtons. X between the surface and the crack. The coefficient of friction between the crack and the surface is 0.2. Mu equals to 0.2. I don't know if you are able to see the question. 0.2. And then calculate the magnitude of normal force acting on the crack. So we want to calculate the magnitude of normal force. So we are using scenario number 2, I think. Scenario number 2, right? Where we are going to do what? You are going to, obviously normal force is going to be affected by Fy. So this will give you normal force plus Fy is equals to mg is equals to Fg. They are balancing like this, which is going to give you normal force is equals to Fg minus Fy, which is going to give you mg minus, here we said Fy is going to be what? Fa sine of theta. So in this case, it's going to be 2 times 9,8 minus F times what? Sine of 20. That is it. So this will give us 19,6 minus sine 20. Sine 20 is how much? Okay, just write it as it is. I don't have my calculator. Sine of 20 F. Right. That is our normal force in terms of F. But we don't have the force applied. Now the second question was asking us to calculate F, the force. So to calculate the force here with a constant force, the object was moving with a constant force. So to calculate F, they gave us frictional force. Alright, and coefficient of frictional force, so it's easy. It means we are using the formula for friction, which is going to be Fk is equals to mu n, which is going to give us Fk is equals to mu, then here normal force is this one, 19,6 minus sine of 20F. So that will give us friction. They say it is 3 equals to 0.2 times 19,6 minus sine of 20F. Then you make F the subject, the formula. Wow. So if you don't know the scenario, then you won't do anything. This question, you think that the exam is difficult whilst it's not. So you just need to go through these scenarios. Take your time and watch this video, and then you will thank me later.